Hi, Ivan here. Today we are going to solve the magic square problem. We define a magic square to be an n times n matrix of distinct positive integers from 1 to root of n square, where the sum of any row, column, or diagonal of length n is always equal to the same number, the magic constant. We'll be given 3 times 3 matrix as of integers in the inclusive range from 1 to 9. We can convert any digit a to any other digit b in the range 1 to 9 at cost of absolute difference of a and b, given as convert it into a magic square at minimal cost. Print this cost on a new line. Note the resulting magic square must contain distinct integers in the inclusive range 1 to 9. Let's see an example here. The matrix is 5, 3, 4, 1, 5, 8, 6, 4, and 2. We can convert it into the following magic square is here. 8, 3, 4, 1, 5, 9, 6, 7, and 2. This took the replacement at cost of 5 and 8, 8 and 9, 4 and 7. This is 3, this is 1, this is 3 all, and answer is 7. The key points in here is the matrix size is 3 times 3, and the allowed numbers is 1 and 1 to 9, and it is a distinct number. And we will kind of do find minimum cost to convert input matrix into a magic square. And the magic square requirement is sum of each row, column, and diagonal must be equal. And our strategy is most possible sum of three distinct 1 to 9 number is 15. Center value must be 5. Values that are allowed to be in the corner include this 2, 4, 6, and 8. With 2 must cross with 8 and 4 must cross with 6. Let's see an example below. This is 8, 6, 4, and 2 for the corner, and 5 and the center. 2 must cross with 8 and 4 must cross with 6. We can move a row, column, or diagonally to fill the empty values, which sum is 15. Let's see example one example here. This is 8, 1, 6, 3, 5, 7, 4, 9, 2. If we sum of the row, by column, or by diagonal, the sum is 15. Wow, one magic square are found. Because magic squares have very strict value rules, center and corner values, so we can assume if there are few variations of magic square. We can use the magic square example that has been found previously to find other variations. Well, keep obey the corner and center value rules by doing rotate and mirror transformation. In here, this is our first magic square found before. If we rotate it 90 degrees clockwise, it will result like this. If we rotate this into 180 degrees clockwise, and we rotate 270 degree clockwise, it will be like this. And if we mirror this to y equal to 0, which is here, this is x, and this is for mirror x to 0. This is y equal to x, and this is y to equal to minus x. Then our solution is in the arrange section, we will kind of define 8 magic square matrix that we found before in one-dimensional array. The 8 is 4, 1, and 3. The 8 magic squares. We will kind of convert input matrix S into one-dimensional array. So for the matrix here, for the magic square template, we will make it one dimension here. Then minimum cost term, min cost, with the init of maximum number of integer 32 bytes. And then in the action section, for each defined magic square, find its cost by getting sum of absolute difference between each magic and input S. Sorry, this is S values. Then we will kind of find minimum value between current cost and current minimum cost. Then at the end out of the loop, we will gonna return min cost. And here we will gonna I already make the example of our magic square that we found before. Then in here we must convert the matrix and store the minimum cost. For minimum cost we must import mat first. Sorry. Yeah. No. This is correct. Alright. So this is we are gonna make the function here. Mm, we're gonna make a empty array here, and we will gonna return it. Here we will gonna iterate through this s, and we will gonna append its value here. All value we iterate through the s here, s I comma j. We will gonna append it to r, and then here for its magic, we will gonna find minimum cost here for its example here for its magic we found before. We will gonna define the cost first. This is for storing the cost for its magic. Then we will gonna find out the total cost for its element in magic and the R here. So here we need a apps function we can take from this. Okay, here. Then in here we will gonna to compare the minimum cost with minimum comparison here. We will gonna use this. In here we use pointer. In here we will gonna compare the recent min cost and the recent cost of magic here. I think it's enough. Let's run the code. It passed the first test case. It passed all the test cases. That's all. If you have any questions or better solutions, write down on the comment section below. And thanks.